Arc of Ages presents. When I say the word physicist, what image comes to mind? Einstein with his wild hair, Feynman with his bongo drums, Hawking in his wheelchair, the greats, the legends, the names everyone knows. Now, let me ask you something. How many black physicists can you name? Go ahead, think about it. I'll wait. If you're struggling, that's not your fault. It's not because black physicists don't exist. It's not because they didn't make groundbreaking discoveries. It's because someone, many someones, across many generations, decided you shouldn't know their names. Here's a fact that should make your brain itch. The technology that makes your phone calls possible, fiber optics, caller ID, call waiting, was built on research by a black woman physicist who was so isolated at MIT that other students refused to sit with her in the cafeteria. She persevered anyway, and most people have never heard her name. The first African American selected to be an astronaut wasn't who you think it was. He was a physicist and test pilot chosen in 1967, before Guyon Bluford, before Mae Jemison, before any of the names you know. He died in a training accident before he could reach space, and history almost forgot him completely. The camera that took ultraviolet photographs from the surface of the moon was invented by a black man from Ohio. A black physicist helped discover the structure of proteins, the very building blocks of life, and watched a white colleague accept the Nobel Prize for work they did together. Welcome back to Arc of Ages. I'm Max Winkler, and today we're doing something different. We're not covering scientists across all fields. We're going deep into one discipline, physics. 10 black physicists who changed our understanding of the universe. 10 names that should be in every textbook, every classroom, every conversation about who built modern science. 10 geniuses who were deliberately written out of history. And here's what makes this community special. You found some of these stories after our previous videos where we covered scientists like Edward Boucher, Elmer Imes, and others. You went digging. You sent us messages at midnight with links to forgotten dissertations, overlooked obituaries, dusty journal articles that hadn't been cited in decades. One of you found a physicist whose work on the atomic bomb remains partially classified, whose very existence was nearly erased from the historical record. Another discovered the first African American ever selected as an astronaut, whose story was overshadowed by those who came after him. You're not just watching history, you're excavating it together. That's what this community does. We dig, we uncover, we refuse to let brilliance stay buried. Physics, the study of matter, energy, space, and time, the most fundamental science, the discipline that explains how the universe works. And for over a century, black physicists have been at the forefront of discovery while being pushed to the margins of recognition. So here's what we're about to do. 10 physicists, from a woman who was so isolated at MIT that she had to fight just to join study groups, and who went on to lead a major research university, to the astronaut who brought a saxophone to space. Their stories span generations of American science. And by the end of this, you're going to feel something. Anger at what was stolen, pride at what was achieved, and power. The power of knowing what they tried to hide from you. The power of truth that refuses to stay buried. Let's go. 1964. The Civil Rights Act has just been signed into law. America is supposedly changing. And in Cambridge, Massachusetts, a young black woman from Washington, D.C. is about to walk onto the campus of MIT, one of the most elite scientific institutions on earth. She's 18 years old. She's brilliant. She's been valedictorian of her high school class. She's won a scholarship to study physics at one of the best universities in the world, and she's about to discover that changing laws doesn't automatically change hearts. Shirley Ann Jackson. Remember that name, because by the time we're done, you're going to understand why it should be as famous as any physicist in American history. Jackson grew up in Washington, D.C., the daughter of parents who emphasized education above everything else. Her father was a postal supervisor. Her mother was a social worker. They told their daughter she could be anything, and they meant it. From early childhood, Jackson was fascinated by science. She collected bees. She studied their behavior. She built experiments in her backyard. And in school, she was unstoppable, graduating as valedictorian of Roosevelt High School with grades that made MIT take notice. MIT recruited her. She was one of fewer than 20 black students in her incoming class at a university with thousands of students. And she was studying physics, a field where black women were almost non-existent. And then reality hit. The other students, white students, didn't want to study with her. When she sat down at a cafeteria table, people would get up and leave. When study groups formed, she wasn't invited. When she asked questions in class, she was often ignored. Think about that. You're 18 years old. You've been told your whole life that you're brilliant, and you are. You've earned your place at one of the best universities in the world, and your classmates refuse to sit with you at lunch. Many people would have crumbled. Many people would have transferred. Many people would have internalized the message that they didn't belong. Shirley Ann Jackson did none of these things. She worked harder. She studied alone when no one would study with her. She excelled anyway. She earned her bachelor's degree in physics from MIT in 1968. And instead of leaving, instead of finding somewhere more welcoming, she stayed for graduate school in the theoretical physics area at MIT. Her doctoral research focused on elementary particle physics, the study of the smallest building blocks of matter. She was working on some of the most complex and abstract problems in all of science. In 1973, Shirley Ann Jackson earned her PhD in theoretical physics from MIT. In doing so, she became the first African-American woman to earn a doctorate from MIT in any field, not just physics, any field, first ever. MIT had been around for over 100 years. It had granted thousands upon thousands of doctoral degrees, and it took until 1973 for a black woman to earn one. Not because black women weren't capable, because the barriers were designed to keep them out. After MIT, Jackson joined Bell Laboratories, one of the most prestigious research institutions in the world, the place where transistors were invented, where lasers were developed, where foundational work of modern telecommunications happened. At Bell Labs, Jackson conducted groundbreaking research on semiconductors, optical physics, and the electronic properties of materials. Her work helped lay the foundations for technologies we use every single day. The touch-tone telephone, the portable fax, solar cells, fiber optic cables that carry your internet connections, caller ID, call waiting, all of these technologies build on research that Shirley and Jackson conducted or directly contributed to. Every time you check your caller ID, every time you put someone on hold to take another call, every time data travels through fiber optic cables, you're using technology that exists because of Shirley Ann Jackson's research. But she wasn't done breaking barriers. In 1995, President Bill Clinton appointed her chairman of the U.S. Nuclear Regulatory Commission, the federal agency that oversees nuclear power plants and nuclear materials. She was the first woman and the first African American to hold that position. She oversaw the safety of every nuclear reactor in the United States. She made decisions that affected millions of lives. She was responsible for ensuring that nuclear technology was used safely and responsibly. And in 1999, she became president of Rensselaer Polytechnic Institute, one of the nation's oldest and most respected technological universities. She led that institution for over 20 years, transforming it into a world-class research university. Under her leadership, Rensselaer's research funding more than doubled. Its reputation soared. She proved that a black woman could not only do physics, she could lead an entire university dedicated to it. Shirley Ann Jackson has received the National Medal of Science, the highest scientific honor in America. She's been inducted into the National Inventors Hall of Fame. She served on countless boards and commissions. And yet, when we tell the story of American physics, the great minds, the breakthrough discoveries, how often is Shirley Ann Jackson mentioned? When high school students learn about physicists, do they learn her name? The girl who collected bees in her backyard, who was isolated by her MIT classmates, who studied alone when no one would study with her, who became one of the most influential physicists of her generation. Shirley Ann Jackson, physicist, leader, trailblazer, the woman who refused to let isolation break her. Say her name and remember, the phone in your pocket carries her fingerprints. Quick question. Who was the first African-American astronaut? If you said Guyon Bluford, the first African-American to actually fly in space in 1983, you'd be giving the answer most people give, but you'd be wrong. If you said Mae Jemison, the first African-American woman in space, you'd also be wrong. The first African-American selected as an astronaut never made it to space, and his story has been nearly forgotten. Robert Henry Lawrence Jr., born in Chicago, 1935, the first African-American astronaut, the man who should have made history, and who did, even though most people don't know it. Lawrence grew up in the south side of Chicago, in the Englewood neighborhood. His father was a disabled veteran. His mother worked to keep the family going. From early on, Robert showed exceptional academic promise. He was a star student at Englewood High School. He was also a chess champion and a track star. He seemed to excel at everything he tried, and what he wanted to try more than anything was flying. He earned a bachelor's degree in chemistry from Bradley University in 1956, graduating in the top 10% of his class. But chemistry wasn't his destination, it was his launching pad. Lawrence joined the U.S. Air Force and earned his pilot's wings. He became an instructor pilot, teaching others to fly, and he kept pushing, kept advancing, kept reaching for something higher. While serving as an Air Force officer, he earned his PhD in physical chemistry from Ohio State University in 1965. A nuclear chemist who is also a combat-rated pilot. Think about that combination of skills. He was selected for the Air Force Test Pilot School at Edwards Air Force Base, one of the most elite aviation programs in the world. He learned to fly experimental aircraft at the edge of what was possible. In 1967, the Air Force was running its own space program, the Manned Orbiting Laboratory, or MOL. It was a military space station program separate from NASA. They were selecting their own astronauts, and they needed the best. On June 30th, 1967, Robert Henry Lawrence was selected as an astronaut for the Manned Orbiting Laboratory program. He was the first African American selected as an astronaut by any space program. First ever. This was 1967. The civil rights movement was in full swing. Martin Luther King was still alive, and a black man had just been selected to go to space 16 years before Guyon Bluford would actually make the journey. Lawrence was training to fly the kind of missions that astronauts would need to perform. Steep descent landings that simulated returning from space. On December 8, 1967, he was in the back seat of an F-104 starfighter supervising a training flight. The pilot in the front seat made an error during the landing approach. The aircraft touched down too hard and too fast. It flipped and crashed. The other pilot was able to eject. Robert Lawrence was killed. He was 32 years old. He had a wife. He had a son. He had been an astronaut for just over 5 months, and he never got to fly to space. The Manned Orbiting Laboratory program was canceled in 1969. The astronauts who had been selected for it were transferred to NASA, some of them eventually on the space shuttle, but Lawrence was already gone. For decades, Robert Lawrence's name was not included on the Space Mirror Memorial at Kennedy Space Center. For decades, Robert Lawrence's name was not included on the Space Mirror Memorial at Kennedy Space Center, the monument that honors astronauts who died in service. Because he was a military astronaut, not NASA, he was excluded. It took until 1997, 30 years after his death, for his name to be added to the memorial. 30 years. The first African-American astronaut, invisible on the monument that was supposed to honor all astronauts who gave their lives. When people talk about the first black astronaut, they almost always mean Guyon Bluford, because Bluford actually flew in space. But first to be selected and first to fly are two different things. Lawrence was first to be selected. He just never got the chance to fly. Imagine what it would have meant if Robert Lawrence had lived, if the first human being of African descent to orbit the Earth had done so in the late 1960s or early 1970s. How would that have changed how young black children saw themselves, how they thought was possible? Robert Henry Lawrence Jr., physicist, test pilot, the first African-American astronaut, the man who should have been first to see Earth from orbit. Say his name. And remember, history isn't just who made it to the finish line, it's also who was running the race. When I say greatest scientific discoveries of the 20th century, what comes to mind? The structure of DNA? The theory of relativity? The discovery of how proteins fold? Here's a name you probably associate with that last one, Linus Pauling. Linus Pauling, two-time Nobel laureate, one of the most celebrated scientists in American history, credited with discovering the alpha helix, the fundamental spiral structure that proteins use to fold into their functional shapes. The alpha helix is essential to understanding how life works at the molecular level. It's foundational to modern biology, medicine, drug development. Pauling got the Nobel Prize for it in 1954. But here's what the Nobel Committee didn't acknowledge. Pauling had a collaborator, a co-author on the original paper, a physicist who did the mathematical calculations that proved the alpha helix structure was correct, and that physicist was a black man, Herman Branson, born in Pocahontas, Virginia, 1914. A physicist who specialized in the mathematics of molecular structures, and the man who should be remembered alongside Linus Pauling for one of the most important discoveries in biology. Branson grew up in a small Virginia town. He was brilliant from the start, graduating from Virginia State College, then earning his PhD in physics from the University of Cincinnati in 1939. He joined the faculty at Howard University, where he built a reputation as an expert in mathematical physics, specifically using mathematics to understand the structures of complex molecules. In the late 1940s, Linus Pauling invited Branson to join his research group at Caltech for a sabbatical. Pauling was working on one of the biggest questions in biology: how do proteins fold? Pauling gave Branson a specific task: use your mathematical skills to analyze the possible structures that protein chains could form. Figure out which shapes are stable and which aren't. Branson worked for months on the calculations. He analyzed the geometry, the bond angles, the stability of different configurations, and he found two stable structures that the protein chain could form. One of those structures was the alpha helix, the spiral configuration that would become one of the most important discoveries in molecular biology. Branson's calculations proved it was mathematically stable. The paper was published in 1951 in the Proceedings of the National Academy of Sciences. 3 authors, Linus Pauling, Robert Corey, and Herman Branson. Branson's name was on the paper. His contribution was documented. 3 years later, Linus Pauling won the Nobel Prize in Chemistry. The citation specifically mentioned his work on the structure of proteins, including the alpha helix. Herman Branson, not mentioned, not invited, not acknowledged. Now, to be fair, the Nobel Prize can only be given to a maximum of 3 people. And Pauling did do extensive work on protein structure beyond just the alpha helix. But here's what's troubling. In subsequent interviews and writings, Pauling rarely acknowledged Branson's contribution. When the alpha helix is discussed in textbooks, Branson's name is often missing. The narrative became, Pauling discovered the alpha helix. Period. Was it deliberate erasure? Was it the normal way that junior collaborators get overshadowed by famous scientists? Was it racism? Probably some combination of all 3. Herman Branson went on to have a distinguished career. He became the president of Central State University in Ohio, then president of Lincoln University in Pennsylvania. He trained generations of black scientists. He was a leader in education. But he never won the Nobel Prize. He never got to stand on that stage in Stockholm. He watched a white colleague accept the highest honor in science for work they had done together. Herman Branson, co-discoverer of the alpha helix, mathematical physicist, educator, the man whose calculations proved one of the most important structures in biology, and who watched someone else get the credit. Say his name, and remember, scientific discovery is often collaborative. Scientific recognition rarely is. World War II. The fate of civilization hangs in the balance. America is racing to develop technologies that could turn the tide. Radar, weapon systems, communications. The military needs the best minds in the country, regardless of race. Almost. The MIT Radiation Laboratory was one of the most important and secret research facilities of the war. Thousands of scientists worked there, developing radar systems that would help the Allies win. And among them was a black physicist whose work on magnetism would prove essential. Warren Henry, born in Evergreen, Alabama, 1909. One of 10 children, his parents were both educators who understood that knowledge was the pathway out of poverty, out of Jim Crow, out of limitation. Henry earned his bachelor's degree from Tuskegee Institute, his master's from Atlanta University, and his PhD in physics from the University of Chicago in 1941, just as America was entering World War II. His specialty was low-temperature physics, how materials behave when cooled to extreme cold. Specifically, he studied magnetism, how magnetic fields affect different substances. This might sound abstract, but it had immediate practical applications. Radar systems depend on magnetic materials. Understanding how those materials behave is essential to building better radar. Henry was recruited to work at the MIT Radiation Laboratory, a black physicist working on classified military research at one of the most important wartime labs in the country. His expertise in magnetism made him invaluable. The radar systems developed at MIT helped win the war. They detected enemy aircraft and submarines. They saved countless Allied lives. And Warren Henry contributed to making them work. After the war, Henry continued his research at the Naval Research Laboratory and later at Lockheed. He published over 100 scientific papers. He made fundamental discoveries about how magnetism works at the quantum level. His measurements of magnetic properties were so precise that they became reference standards for other researchers. Like Elmer Imes before him, Warren Henry was the person who provided the data that everyone else relied on. He eventually joined the faculty at Howard University, where he mentored generations of black physicists. He taught students who went on to work at NASA, at national laboratories, at universities around the country. And when we tell the story of World War II physics, of radar development, of the scientists who helped win the war, how often is Warren Henry mentioned? How often do the history books acknowledge the black physicist whose expertise in magnetism contributed to the victory? Warren Henry lived to be 92 years old. He witnessed the entire arc of black physics in America, from the era when there were barely a handful of black PhDs to the time when black physicists were working at NASA, at major universities, at the frontiers of science. He was a bridge between generations. Warren Henry, low-temperature physics, magnetism, radar, the man who helped win a war and train a generation. Say his name. The Manhattan Project, the most secret, most expensive, most consequential scientific project in human history. The race to build an atomic bomb before Nazi Germany could. Thousands of scientists, billions of dollars, the fate of civilization. The names we remember: Oppenheimer, Fermi, Teilhard, Gillard, white men, all of them, or at least the names that made it into the history books. But here's what those history books don't tell you. There were black scientists on the Manhattan Project. Not many. The racism of the era made sure of that. But they were there. At least 6 black scientists contributed to the atomic bomb project, and almost no one knows their names. Lloyd Quarterman, born in Philadelphia, 1918, raised by his grandmother after being orphaned young. He showed exceptional promise in science and went on to earn his degree in chemistry from St. Augustine's College in North Carolina. In the early 1940s, Quarterman was recruited to work on the Manhattan Project. Specifically, he worked on the purification of uranium, the radioactive element that would power the atomic bomb. This was dangerous work, handling radioactive materials without fully understanding the long-term health effects, working in secret, under constant pressure, knowing that the outcome of the war might depend on what you discovered. Quarterman was present at one of the most historic moments in the history of science. On December 2nd, 1942, Enrico Fermi led the team that achieved the first controlled nuclear chain reaction right under the bleachers of a squash court at the University of Chicago. Lloyd Quarterman was there, a black scientist present at the birth of the nuclear age, one of the few people on Earth to witness that historic moment. And how many people know his name? After the war, Quarterman continued his research at Argonne National Laboratory, specializing in fluorine chemistry. He developed new techniques for handling dangerous fluorine compounds that were essential for nuclear research. He invented new laboratory instruments, including a special spectrophotometer for studying fluorine compounds. He published research. He trained other scientists. He spent his career advancing nuclear science. And when we tell the story of the Manhattan Project in documentaries, in textbooks, in movies, the black scientists are almost never mentioned. The contributions of Lloyd Quarterman and his colleagues disappear into the mythology of Oppenheimer and the white scientists around him. Lloyd Quarterman died in 1982. He was one of the few people who could say they were present when humanity unlocked the power of the atom, and most people have never heard his name. Lloyd Quarterman, present at the birth of the nuclear age, fluorine chemistry pioneer, a black man who helped build the bomb. Say his name and remember, the Manhattan Project wasn't just Oppenheimer. It was thousands of scientists, including those whose names they tried to erase. We're about to tell you about a physicist whose story we almost couldn't piece together, whose photograph is nearly impossible to find, whose very existence was almost erased from history. She gave her life to the atomic bomb project, and she died because of it. The Dayton Project was a secret part of the Manhattan Project, based in Dayton, Ohio. Its mission? Develop polonium triggers for atomic bombs. Polonium, one of the most radioactive elements on Earth. Carolyn Beatrice Parker. We don't know exactly when she was born. We don't have a clear, widely available photograph. We can barely piece together her educational history. That's how thoroughly she was erased. What we know is this: she earned degrees from Fisk University, including advanced work in physics. She may have continued her studies at MIT in an era when black women in physics were almost non-existent. She persevered. During World War II, she was recruited to work on the Dayton Project, a black woman physicist working on classified atomic weapons research. Think about how rare that was. Think about the barriers she must have overcome just to be in that room. Her work involved handling polonium directly. In the 1940s, scientists didn't fully understand how dangerous radiation was. Safety protocols were inadequate. Equipment was primitive. Scientists absorbed radiation doses that we would consider horrifying today. Carolyn Parker developed leukemia, blood cancer, almost certainly caused by radiation exposure from her work. The country she served, the secret, essential work she did, poisoned her. She died in 1966, a black woman physicist who gave her life to the atomic bomb project. And when she died, almost nobody outside of her family knew what she had done or what she had sacrificed. Here's what haunts us about Carolyn Parker. We don't have a clear photograph of her. We don't know her exact birthday. We can't verify all her educational records because some were lost or never properly preserved. A black woman who worked on the atomic bomb, who died from radiation exposure, and we can barely prove she existed. That's not an accident. That's systematic erasure. Carolyn Beatrice Parker, physicist, patriot, sacrificed, erased, but not anymore. Not in this community. We say her name, even though we can't clearly see her face. We honor her work, even though much of it remains classified. Say her name, Carolyn Beatrice Parker, and when you do, understand you're one of the few people who will. That's why this matters. That's why we do this. Okay, let me pause here. We're about halfway through, and I want to check in with you. If you're feeling something right now, grief, anger, frustration, determination, that's appropriate. These stories are heavy. They should be heavy. The weight you're feeling is the weight of injustice that went unchallenged for too long. I've been reading your comments since this video went live. Physics students saying they've never heard these names. Teachers saying they're adding to the curricula. Parents saying they're having new conversations with their children about who does science. That's the power of this community. We're not just watching history, we're excavating it, we're restoring it. We're making sure the next generation grows up knowing that people who look like them have always been at the forefront of understanding the universe. So, if you haven't already, hit that subscribe button, join this community, and hit that like button, not for me, for Shirley, for Robert, for Herman, for Warren, for Lloyd, for Carolyn. Every like is an act of remembrance. Every like helps more people find this video. All right, 4 more physicists to go. And I promise you, these next 4 stories are going to be just as powerful. Take a breath and let's continue. April 1972. Apollo 16. Astronauts John Young and Charles Duke are walking on the surface of the moon. They're carrying a piece of equipment that will capture images no human has ever seen before. Ultraviolet photographs of distant stars and galaxies. That camera, the Far Ultraviolet Camera Spectrograph, is taking pictures of the universe that can only be captured from space. Earth's atmosphere blocks ultraviolet light, so these images are impossible to get from the ground. The images reveal new details about stars, about the interstellar medium, about how galaxies form. They're scientifically invaluable, And the man who invented that camera, who designed it, who made it work, was a black physicist from Ohio. George Carruthers, born in Cincinnati, 1939. From childhood, he was fascinated by space, by stars, by the machinery that could help us understand the universe. He built his first telescope when he was 10 years old. He earned his bachelor's, master's, and PhD in physics from the University of Illinois, specializing in astrophysics. His doctoral research focused on atomic nitrogen in interstellar space, the stuff between the stars. After earning his doctorate in 1964, Carruthers joined a naval research laboratory in Washington, D.C., and that's where he began developing the technology that would make history. Ultraviolet light from space can't penetrate Earth's atmosphere. That's good for us. UV radiation is harmful, but it means we can't study the universe's ultraviolet emissions from the ground. You need to get above the atmosphere. Carruthers developed detectors that could capture ultraviolet images from space. His instruments flew on sounding rockets in the 1960s, taking quick snapshots before falling back to Earth. The data was revolutionary. And then NASA came calling. They wanted a camera for the Apollo missions, one that could take ultraviolet images from the surface of the moon. Carruthers designed it, the Far Ultraviolet Camera Spectrograph. On April 21, 1972, astronaut John Young set up Carruthers' camera on the lunar surface. It pointed at Earth, at distant galaxies, at stars, capturing images that had never been possible before. For the first time, we could see Earth's hydrogen corona, the outermost layer of our atmosphere, visible only in ultraviolet light. We could see details of distant stars that ground-based telescopes couldn't capture. Carruthers' invention expanded human knowledge of the cosmos. George Carruthers was eventually recognized. He was inducted into the National Inventors Hall of Fame in 2003. He received the National Medal of Technology and Innovation. His camera is on display at the Smithsonian's National Air and Space Museum. But when we tell the story of space exploration, the Apollo missions, the journey to the moon, how often do we mention the black physicist whose camera captured images from the lunar surface? How many people know that one of the instruments on the moon was invented by a black man from Ohio? George Carruthers died in 2020. He spent his entire career advancing our understanding of the universe. His technology is still being used and refined. The questions he helped answer led to new questions that scientists are still exploring today. George Carruthers, his invention is on the moon. His legacy is in the stars. Say his name and remember, when you look up at the night sky, a black physicist helped us see what's really there. The sun, 93 million miles away, a nuclear furnace that makes all life on Earth possible. For thousands of years, humans could only study it by looking at the light it emits. But there's so much more to the sun than visible light. The sun emits X-rays, high-energy radiation that reveals details invisible to ordinary light. The solar corona, the sun's outer atmosphere, blazes with X-ray emissions that can tell us about solar activity, about magnetic fields, about the physics of our star. But capturing X-ray images is incredibly difficult. You can't just point a regular camera at the sun and get X-ray pictures. You need special telescopes with mirrors that can focus X-ray light. And one of the pioneers of this technology was a black physicist from Cleveland. Arthur B.C. Walker Jr., born in Cleveland, 1936, a physicist who would revolutionize how we see the sun and who mentored one of America's most famous astronauts. Walker earned his bachelor's degree from Case Institute of Technology, now Case Western Reserve. Then his master's and PhD in physics from the University of Illinois. His specialty? High-energy physics and the behavior of particles in extreme environments. He worked at the Air Force Weapons Laboratory, then at Aerospace Corporation, before joining Stanford University as a professor, one of the few black faculty members in physics at a major research university. At Stanford, Walker did groundbreaking work on X-ray and ultraviolet imaging of the sun. He developed multi-layer mirror technology that could focus X-rays, which normally just pass through regular mirrors, creating sharp images of solar activity. His work led to the first high-resolution X-ray images of the solar corona. For the first time, scientists could see the sun's outer atmosphere in detail, watching magnetic loops and plasma structures that were invisible before. This wasn't just pretty pictures. Understanding the solar corona helps us predict space weather, solar flares, and coronal mass ejections that can damage satellites, disrupt communications, even affect power grids on Earth. Walker's technology has practical, life-saving applications. But here's something that nobody knows. Arthur Walker was Sally Ride's doctoral advisor at Stanford. Sally Ride, the first American woman in space, earned her PhD under the guidance of a black physicist. Walker mentored Ride through her doctoral research in astrophysics. When she became a national icon as the first American woman to go to space, how often was her black mentor mentioned? How often did the story include Arthur Walker? Arthur Walker died in 2001. He had transformed solar physics, helped develop space technology that we still use today, and mentored one of the most famous astronauts in American history, and most people have never heard his name. Arthur B.C. Walker Jr. He showed us the sun in ways we'd never seen it before. He trained one of America's space heroes. Say his name and remember, behind every famous figure, there are often invisible mentors whose contributions are forgotten. How many black women physicists can you name? I asked you about black physicists at the start of this video. Now I'm asking specifically about black women. Names, please. If you're struggling even more now, that's because black women in physics have been doubly erased, once for their race, once for their gender. The barriers they faced were astronomical. The recognition they received was microscopic. Willie Hobbs Moore, born in Atlantic City, New Jersey, 1934, the woman who would become the first African-American woman to earn a PhD in physics in the United States. Moore showed exceptional promise from childhood. She earned her bachelor's degree in electrical engineering from the University of Michigan in 1958, then her master's in physics, and she kept going. In 1972, Willie Hobbs Moore earned her PhD in physics from the University of Michigan. In doing so, she became the first African American woman to hold a doctorate in physics in the United States history. First ever. Think about what that means. It was 1972. Women had been fighting for equal rights for decades. The civil rights movement had just transformed American law, and still it had taken until 1972 for a black woman to earn a physics doctorate. Her research focused on vibrational analysis of organic compounds, using light to understand how molecules vibrate and what those vibrations tell us about their structure. This is essential work for chemistry, for material science, for understanding how matter behaves. After earning her doctorate, Moore joined Ford Motor Company as a research physicist. She applied her expertise in vibrational analysis to automotive engineering, understanding how materials in cars behave under stress. Her work contributed to making cars safer and more efficient. Every time you drive a vehicle that's been optimized for performance and safety, you're benefiting from the kind of physics research that Willie Hobbs Moore pioneered. And when we tell the story of women breaking barriers in physics, Marie Curie, Lisa Meitner, Chien-Shiung Wu, how often do we include Willie Hobbs Moore? How often does the first black American woman with a physics PhD get mentioned alongside other pioneering women? Willie Hobbs Moore died in 1994 at just 60 years old. She had broken a barrier that no black woman in American history had broken before. Even people who care about women in science have never heard her name. Willie Hobbs Moore, first physicist, engineer, barrier breaker. Say her name, and remember, the story of women in physics isn't complete without her.
Engine start. 4, 3, 2, 1, and liftoff.
January 28, 1986, 11:39 a.m. Eastern Time. Space Shuttle Challenger lifts off from Kennedy Space Center in Florida. 73 seconds later, it breaks apart. 7 astronauts are killed. The nation watches in horror. Among the 7 crew members was a physicist, a man who had overcome barriers that would have stopped most people before they even started. A man who once got his library books delivered by police escort because a white librarian refused to serve him. A man who brought his saxophone to space. Ronald McNair, born in Lake City, South Carolina, 1950, a small town in the Jim Crow South where black children were expected to know their place and where one small boy refused to accept any limit. When Ronald was 9 years old, he walked into the Lake City Public Library to check out some books. The librarian refused to serve him. This library, she said, was for white people only. Ronald didn't leave. He sat down and refused to move. The librarian called the police. She called his mother, and when the adults arrived, expecting to drag the stubborn child out, something unexpected happened. The police officers and Ronald's mother looked at this determined 9-year-old and decided he should be allowed to check out his books. He won. A child stared down Jim Crow and won. That's who Ronald McNair was from the very beginning. Today, that library is named the Ronald E. McNair Life History Center. The same building that tried to exclude him now honors his memory. McNair earned his bachelor's degree in physics from North Carolina A&T State University, graduating magna cum laude. Then he went to MIT, the Massachusetts Institute of Technology, for his doctorate. At MIT, he specialized in laser physics, the study of concentrated, coherent light and its interaction with matter. His doctoral research focused on chemical lasers and their applications. He earned his PhD in 1976. In 1978, NASA selected McNair as an astronaut candidate. He was one of the first Black Americans ever selected for the astronaut program. He trained for years, preparing for the moment he would leave Earth. His first space flight came in 1984, aboard the same shuttle, Challenger, that would later take his life. He was a mission specialist responsible for operating equipment and conducting experiments. And here's something that shows you who McNair really was. He brought his saxophone to space. He was an accomplished musician, a holder of a 5th-degree black belt in karate, a man of many talents and passions. He wasn't just a scientist. He was fully, vibrantly human. In fact, composer Jean-Michel Jarre had created a piece for McNair to perform from orbiting during the 1986 mission. McNair was going to play saxophone from space, broadcasting music back to Earth. That performance never happened. 73 seconds after launch, a failure in the O-ring seals. The shuttle broke apart. Robert McNair, along with 6 crewmates, was killed. He was 35 years old. Today, there's a crater on the moon named after Robert McNair. A building at MIT bears his name. Schools across the country honor him. The Ronald E. McNair Post-Baccalaureate Achievement Program helps underrepresented students prepare for doctoral studies. But here's what matters most. Ronald McNair's story isn't just about tragedy. It's about a boy who refused to be excluded, who stared down racism when he was 9 years old, who earned a PhD from MIT, who became an astronaut, who reached the stars. He once said, "Before you can make a dream come true, you must first have one. Ronald McNair had dreams that Jim Crow couldn't kill, dreams that poverty couldn't crush, dreams that even death couldn't fully silence. Ronald Irwin McNair, physicist, astronaut, the boy who wouldn't leave the library. Say his name and remember, the stars are for everyone. 10 physicists, 10 geniuses who changed our understanding of the universe. 10 names they tried to bury. Shirley Ann Jackson, first black woman to earn a PhD from MIT, isolated by her classmates, built the technology in your pocket. Robert Henry Lawrence Jr., first African American selected as an astronaut, died before he could reach space, nearly forgotten. Herman Branson, co-discoverer the alpha helix, watched someone else accept the Nobel Prize. Warren Henry, magnetism pioneer, helped win World War II, rarely mentioned in the history books. Lloyd Quarterman, present at the first nuclear chain reaction, name forgotten. Carolyn Beatrice Parker gave her life to the atomic bomb project, nearly erased from existence. George Carruthers invented the camera that took pictures from the moon, still overlooked. Arthur B.C. Walker revolutionized how we see the sun, mentored Sally Ride, invisible in the stories we tell. Willie Hobbs Moore, first black American woman to earn a PhD in physics, left out of women in science narratives. Ronald McNair, laser physicist, astronaut, killed pursuing his dream at 35 years old. Physics, the most fundamental science, the discipline that explains how the universe works, from the smallest particle to the largest galaxies. And for over a century, black physicists have been at the forefront of discovery while being pushed to the margins of recognition. These 10 people and hundreds more whose names we haven't yet uncovered built the foundations of modern physics. They proved theories. They invented technologies. They mentored students who became legends. And the textbooks pretended they didn't exist. That's what we're correcting. That's why this community exists. That's why you're here, watching, learning, feeling whatever you're feeling right now. We've been reading your comments since this video went live. Physics students saying they've never heard these names. Teachers saying they're adding them to curricula. Parents saying they're having new conversations with their children about who does science. That's the power of this community. We're not just watching history, we're excavating it, we're restoring it. We're making sure the next generation grows up knowing that people who look like them have always been at the forefront of understanding the universe. So here's what we need you to do right now. Drop a comment. First, which physicist's story hits you the hardest? We want to know. The community wants to know. Second, who should we cover next? What names have you discovered? What stories need telling? Help us build the next excavation. Hit that like button. Not for me, for Shirley, for Robert, for Herman, for Warren, for Lloyd, for Carolyn, for George, for Arthur, for Willie, for Ronald. Every like is an act of remembrance. Every like helps more people find this video. Subscribe and hit that notification bell, because we're not stopping. There are more physicists whose stories need telling, more scientists across every field, more truth waiting to be uncovered. If you're not subscribed, you'll miss the next excavation. And share this video right now. Send it to someone who needs to see that physics has always been for everyone. Send it to a student struggling in physics class who needs to see themselves in the field. Send it to a teacher who wants to tell the complete story. Send it to anyone who still believes the lie that science was built by white men alone. Say them with me: Shirley Ann Jackson, Robert Henry Lawrence Jr., Herman Branson, Warren Henry, Lloyd Quarterman, Carolyn Beatrice Parker, George Carruthers, Arthur B.C. Walker Jr., Willie Hobbs Moore, Ronald Erwin McNair. Say them out loud. Let your voice carry their names into the world. Remember them, share them, teach them. And when you do, when you say these names, when you share these stories, when you refuse to let these legacies stay buried, understand what you're accomplishing. You're not just learning physics history, you're rewriting it. Every previous Arc of Ages video added fuel to a fire that's been building for years. This video adds more, and together, this community, this movement, these millions of people committed to truth, we're burning through a century of erasure. The arc of history is long, but it bends towards truth. And we, you, me, everyone watching this right now, we are the ones bending it. Somewhere, right now, a young person is watching this video. Maybe they're in high school, thinking about what to study in college. Maybe they're already in college, feeling like they don't belong in their physics class. Maybe they're a child who loves science, but has never seen anyone who looks like them in a physics textbook. To that person, you belong. You've always belonged. The proof is in these 10 stories. The proof is in the hundreds of black physicists whose names we haven't even found yet. The proof is in your own curiosity, your own questions, your own desire to understand how the universe works. The universe doesn't care about your race. Photons don't discriminate. Gravity pulls on everyone equally. The laws of physics apply to all of us, and understanding them is the birthright of every human being. You're not just a viewer. You're not just a subscriber count. You're part of a community that's reclaiming stolen legacies, that's uncovering buried brilliance, that's making sure the story of physics includes everyone who contributed to it. This is what we do at Arc of Ages. We don't just learn history, we excavate it. We pull it from the archives, dust it off, hold it up to the light and say, this happened, these people existed, and they mattered. Thank you for being here. Thank you for watching. Thank you for feeling whatever you're feeling right now. The grief, the pride, the anger, the determination. All of it is valid. All of it is fuel. Thank you for digging with us. Thank you for refusing to let brilliance stay buried. Thank you for being part of something bigger than any single video. I'm Max Winkler. This is Arc of Ages, and I'll see you in the next excavation. If you want to keep digging, click here for our previous videos. More scientists, more stolen legacies, more names you need to know. And if you haven't subscribed yet, do it now. The next excavation is coming, and trust me, you don't want to miss it. One more thing, I want to leave you with some hope. The next generation of black physicists isn't waiting to be discovered. They're working right now in universities, in laboratories, at NASA, at particle accelerators around the world. People like Neil deGrasse Tyson, who became one of the most famous scientists in the world, like Hakeem Oluseyi, who went from the streets of Houston to becoming an astrophysicist, like the hundreds of black physics students graduating every year who are building on the foundations laid by the 10 people we talked about today. The difference is this time we're not going to wait for history to forget them. This time we're telling their stories while they're still being written. That's the world we're building. That's what this community is for. I'll see you next time.